So you're gonna take out your ESRT, you're gonna take out your new packet, which we got yesterday. Again, was everybody here yesterday? You do not have, so Tyler, put the new packet on your desk. You're gonna open that up to page 2. I have posted everything on Teams, I think. So if you go into your team, so yesterday we did the notes on page 1. I even posted a picture of those notes. So if you did not get the notes from yesterday, they are there. And that's it from yesterday. So sorry, let's get started here. You should put the notes in, yes. They're on Teams. You can get them whenever we get there or whenever you get a chance. All right, so we are going to move on to using your reference table. So I started to talk about this yesterday and kind of got a little flustered because I was trying to rush and it wasn't going well. So again, if everybody could turn to page 14 in your reference table. Oh, I should also mention, go ahead, that you are going to have homework today. It's going to be pages 3 and 4 in your packet. We're going to have plenty of time to get started with that. It is 25 questions. So, but like I just said, we will have plenty of time to do those in class, or at least do like 10 to 15 of them in class. They only have 10 to 15 for homework. It's all straight out of your reference table, so it's not so bad. So again, page 14 of your reference table. I'm going to kind of start over again because I definitely did not do a great job. And actually, can I ask one favor of everybody in the front row? Can you move your desks back 1 block? Thank you. I felt like you guys were way too close to me. I was starting to feel a little claustrophobic. I don't know why they keep moving my chairs around. Anyway, so back to this. I'm going to start over again because I know I started rushing really bad yesterday. So this is a graph. So it actually is 3 separate graphs. But this graph is not as pretty as the graphs we did last chapter. What do I mean by that? Last chapter, it was nice and easy. You had pressure perhaps here, pressure increasing, and then you had density here. As pressure increased, density went up. Nice and easy, and you read that as pressure increases, density increases. You can't read this one the same way because as you can see, the temperature changes depending on which one you're in. So it's not quite as simple as the graph we read before. And this one can be read that way, and it would say as pressure increases, altitude decreases. However, we don't talk about the atmosphere like that. So even though these are graphs, I kind of want you to think about them more as a picture of the atmosphere. Let me see, actually pull up, I think, well, not Facebook. So this would be a similar picture. I actually cut this out right in my PowerPoint so I don't have to look for it later. Not the right one. All right, anyway. So this would be a similar picture. Again, it doesn't have all the same things we were looking at, but here you can see the ground is on the bottom and it's going up into the atmosphere. And that is exactly what we're looking at on our reference table. Yes, Tyler. I already told you page 1. No, we did this yesterday. I'm starting over again right now. So you should be on page 14 of your reference table. So this is the ground right here. It says sea level 0. So this is the ground right here, and this is a picture of the atmosphere as you're going up. And I mentioned this yesterday. You have kilometers and miles above the sea listed here on the y-axis. And like I said yesterday, just make sure you read carefully because they are going to try to trick you. They're going to give both sets of right answers, and you need to make sure they say either kilometers or miles. I don't remember if we labeled the ground in your class. So the ground is 0 kilometers or 0 miles above the sea. So that's the ground where we are standing. And then as you go up into the atmosphere, you will get higher in the kilometers or the miles. Yeah. So a couple things before I completely answer that, I do want to point out that the thermosphere really goes up to 600 kilometers. So here it ends at 160, but it really goes up to 600 kilometers. So it doesn't end just because the graph ends, but the graph would just keep going up and up and up. So instead of taking up a huge amount of space, they just end it. And yes, at the edge of the thermosphere is, I don't know about the whole gravity part, but that's where like the atmosphere ends and space begins. So I don't know how much, there is still some gravity out there, but I don't know how much. Does that kind of answer your question? I know I didn't do a good job. Planes fly, that would have been my next thing I would talk about. Planes fly, they either fly, if they're kind of low, like commercial airliners, they hover right around here at the tropopause. And the reason for that, there is a reason, and it comes over to this water vapor concentration. So it's kind of using this to jump around a little bit. Water vapor is the amount of water in the air. Why do you think the graph ends here? Why do you think it's so short? Nah, not because it wants to. Water doesn't go higher. This is the last place water will be. And so there is no water up here in most of the stratosphere, no water in the mesosphere, and no water in the thermosphere. Why do I bring up water and planes? Clouds. Those of you who have ever ridden in an airplane or flown in an airplane, I guess is what you should say, is the turbulence. What causes turbulence, do you know? Air, it's bad weather. So it could be the wind, it could be rain, it could be a storm. So planes like to fly above the clouds. And those of you again who've been on planes, most of the time you look out and you see the clouds below you and blue skies above you. And that's because, again, they want to get above the clouds because they want to get above the weather. So planes fly, if it's a good day, they fly a little lower because they want to go a little lower because they have to use less fuel to get there. But if it's a yucky day, they go up above into the stratosphere. Any more questions, Jonah?
No. If you look down,
so you're way, I mean, I guess technically you can, but you are, I mean, even if you're not up to 600, if you are down here, I mean, you'll be seeing similar, I don't know where how high let's see. There you go. So according to this graph here, satellites fly at 300 kilometers. So that's still about double this in height. So satellites, when they take pictures, it's not officially space. They're still hovering into just the outer edges of our atmosphere. There is still some gravity because that's how satellites stay in space, is they're at a happy place where they have enough gravity where they're not flying out into space, but not too much gravity where they're being pulled into Earth. So there's still some.
So I went out there.
I mean, you wouldn't survive, but in theory, yes. So here's just this says this is a sounding rocket. I'm not exactly sure what that is. But yeah. So let's keep going though. Back to the reference table. So this graph right now is just like any other graph, just like when we had this graph. If we had numbers here, so let me just make up some numbers. How would you figure out the density when I said the pressure is 4? So let me ask you again, how would you figure out the density on this graph when I said the pressure is 4? Catherine?
You would look at where the line pointing above the 4.
Go to 4, now what do I do?
Go up until it reaches.
Go up till you hit the line, and then you go over. So according to my graph, it would be 4. Again, just totally make those numbers up. But you guys know how to read graphs. You go to the number on the x-axis, you go up till you hit the line, you read over. You also know you could read them backwards. So if I said the density is 2, what's the pressure? You go from the density of 2, you hit the line, and you go down. So according to my graph, again, 2. Again, made it up completely. This works the same way. So if I want to know at what altitude can the temperature be 0 degrees? So let me say that again. At what altitude can the temperature be 0 degrees? I want you guys to do this. Look on your graphs or look at mine. I'll say it again. At what altitudes can the temperature be 0? No, okay, so yes, you answered stratosphere. I didn't ask for what layers, I asked for what altitude. So again, that's a classic Regents trick. Make sure you always answer the question that's being asked. What do you got? Sorry, go ahead. One could be here at 50 kilometers. Is there more? One could be right here at the bottom of the troposphere. So all you have to do is go to 0, go up till you hit the line. So there's 1. So maybe like 5 kilometers. Here could be another one at close to 50. And here could, what? 65, 55, 60, 65. Let's see. 60 to 65 would work. Yep. So you guys know how to read graphs. It's not that bad. So let's see if we can figure this out. I want to go to page 2 of your packet. And let's see if you can do this. Oh, I don't remember if I started the boundaries with you. Did I start boundaries with you guys yesterday? Perfect. So what's the name of the boundary that separates, first let's do the troposphere and the stratosphere. Tropopause. So here's the troposphere, here's the stratosphere. The boundary or the fence in between them is the tropopause. The ozone layer is actually part of the stratosphere. It's not an official layer of the atmosphere. It is just part of the stratosphere. What's the boundary between the stratosphere and the mesosphere? The stratopause. So here's the stratosphere, here's the mesopause, or I'm sorry, here's the stratosphere, here's the mesosphere. The stratopause is the boundary between them. And finally, between the mesosphere and the thermosphere, yep, mesosphere, thermosphere, the fence is the mesosphere, mesopause. So I just messed up like 3 times saying the wrong word, and that's again something they expect you to do. They expect you to say mesopause when you mean mesosphere and vice versa. So, or to read them incorrectly. So make sure you read carefully. All right, so the first thing we gotta do to make sure we can read these, let's go to the troposphere. So the troposphere is this very skinny layer right here. It is the one closest to Earth. It is the one that is most important. I want the highest altitude. Everybody go ahead and start filling in this chart and call me over if you need help. Let's do it that way. I want the highest altitude. Actually, let me do one of them with you together. So we'll do this, the troposphere. What is the highest altitude? So what's the name of the highest spot in the troposphere? What's the name of that place? The tropopause. So the troposphere, the top of the troposphere is the tropopause. This is like the ceiling of the troposphere. And I want in miles first. Like 7 or 8 works for me. And what is the in kilometers then? I would say it's not quite 15, but that would have been fine. I would have gone with more, a little bit closer to 10, because it's definitely not halfway, but 11 or 12 would work. Sorry, I thought you guys could see my answers. Then it wants the temperature range. So it wants where it starts and where it ends. What is the temperature at the bottom of the troposphere? Is it 0? It is 15. So here at the ground, the temperature is 15 degrees Celsius. And then at the top of the troposphere, so the tropopause, -55. Now notice oh, you cannot see that, sorry. So notice they even gave you these dotted lines, so you don't even have to estimate. So the troposphere at the ground starts at 15 degrees Celsius, and by the time you get to the top, it gets to -55. All right, I'd like you guys to spend some time and go through that chart. So take a few minutes and fill in that chart. And for temperature, we just want where it starts and where it ends. All right, looks like everybody's on a roll with these. Let's make sure you got it. So for the stratosphere, we want the highest altitude for the stratosphere. So here's the top of the stratosphere. If we go over, I got approximately 31 or 32 miles. And I put right on 80, or I'm sorry, right on 50 kilometers. The temperature for the stratosphere, the bottom of the stratosphere is right here. So here's the temperature, that's -55. And the top is right at 100. So the stratosphere was 31 miles, 50 kilometers, -55, and 0 degrees. So for the mesosphere, I got right at 50 and right at 80, which went from 0 to -90. The thermosphere, this one was tricky. So if you stopped it here and said, what is that, about 75 or maybe a little higher than 75, you did not remember what we circled right here. It exceeds to 600 kilometers. So what I did is I left the miles blank. Now, a few of you said, well, I converted that 600 to miles. You don't need to do that. If it's not on the reference table, you do not need to know how to do it. So don't do extra. Because by the way, on the regions, if you do extra and you do it wrong, I have to mark it wrong. So only ever do what they ask you to do. And I know I technically asked you, but now I'm telling you, you don't have to do that. So it goes to 600, and then it does start here at the bottom of the thermosphere is -90. Do not put -100 because that dotted line goes down to -90. I did, however, say it did not end at 100. We don't know what it ends at, so I said 100 plus. Because we don't know exactly what it ends at. All right, let's answer a few questions about this. Which layer is most of the water vapor in? Good. Did anybody think the stratosphere?
No.
A lot of people think the stratosphere because that's where the top of the graph is. But how much water is there in the stratosphere? Little to nothing. It's practically on the zero. So the layer that has the most is the troposphere. Again, be careful you don't write tropopause. It asks what layer, and the layers are the spheres. Name the layer closest to Earth's surface where the temperature is increasing as you increase altitude. Everybody take a second to do question 2 and don't get tricked. I want everyone to do it without saying anything out loud and don't get tricked. So I want where the temperature is increasing. Devin, I see you writing something. What'd you write? Devin is correct. Stratosphere. So I heard someone shout out thermosphere. Why'd you say thermosphere? Because of the temperature? Temperature is definitely increasing, and it is the place that's the hottest. But the question said where the temperature is increasing. So, and it also said the layer closest to Earth. Did anybody just put troposphere? Because that would have been the first trick I would have thought you would have got caught up in, because it is the layer closest to Earth. But the temperature in the troposphere is going from 15 to -55, so it's decreasing. The stratosphere, the temperature goes from -55 to 0. It's still cold as the Jesus, but it is getting warmer, so that is the layer. Huh? Where? Yeah, in the thermosphere, it's getting real hot. So once you get past up into the thermosphere, it's getting hotter than boiling water. So yes. So remember how we said you wouldn't survive? That's one reason you wouldn't survive. You, well, before you got there, yes. So if you just like floated up, yes, you would freeze before you got there. Tyler, what? Will you tell me which layer is closest to the earth where the temperature is decreasing? Nope, the troposphere, the temperature is actually decreasing. It goes from 15 to -90 or negative. Did I say decreasing? Sorry. You would have been answering the question I said. Sorry, Tyler, but question 2 does ask where it's increasing. So that's the thermal, or the, oh geez, Louise, the stratosphere. Sorry, do you see on the graph though what's happening? So this line right here, as you get higher, when you start on the ground, you're getting a colder temperature. And then when you get going higher up here, you're going warmer, colder, warmer. Number 3 is the question almost everybody gets wrong. Read it and see if you can answer it. What happens to the pressure as you increase altitude? So when you get higher in the sky, what happens to the pressure? It does go down. So let's take a look. It does go down. And this is where it gets a little backwards for how we're used to reading graphs. We're used to reading the x-axis. So as pressure increases, altitude decreases. But that's not how they worded the question. They wanted to know as you get higher in the sky. So as you go from the ground, what is the pressure at the ground, by the way, if you were standing here? The pressure is 1. And then as you go higher in the sky, so let's go to about here. So if this is Jonah floating up in the sky, like he's talked about a couple times now. Jonah, when you're that high in the sky, what about is the pressure there? Hang on, ask Jonah. Go ahead, Jonah, about. Oh, 0.2 or 0.25. So by the way, there's 0.25, 0.5, 0.751. So the pressure does go down. And as you get up here, it's practically 0, right? And Jonah, I think that's what you asked, and it just stays there. Yeah, it stays practically 0 for the rest of the trip up into the atmosphere. So it starts at 1 on the ground and gets closer to 0. So the pressure decreases. What happens? What's the atmospheric pressure at sea level? Oh, we just did this one. At sea level, the pressure is 1. What is the temperature at the tropopause? So everybody go to the tropopause. Here's the tropopause. I want to know the temperature. Anya, did you get the temperature? Huh? You're trying. Can you try to give me the answer? Yeah. At the tropopause. Tropopause. No, so here's the tropopause. We want where the tropopause hits the temperature line. You got it. At what boundary is the coldest temperature? So everybody go onto your graph. I'm going to just call on random people, so get ready. What boundary, so what dotted line has the coldest temperature? Daisy, do you see the coldest temperature? Which boundary? You got it right here. This is the coldest it gets, the furthest to the left. So it's -90 at the mesopause. Oh, here's some scientific notation. We did this last chapter. Name the boundary where the pressure is approximately 1 × 10⁻³ We've got 1. The decimal point lives here. What do I do with that -3? Move it 3 to the left. 1, 2, 3. So where is the pressure? 0.001, and it says what boundary? So process of elimination, there's only 3 boundaries. Is it at the tropopause? No, we already established that one's about 0.25. So here's the stratopause, here's the mesopause. To be perfectly honest, it's both. They're both practically 0. And so we can put one or the other or both. So stratopause, can't spell it, stratopause or mesopause. In which layers of the atmosphere can the temperature be 15 degrees Celsius? So they said layer, actually they said layers. So not pauses, but actual layers. Can the temperature be 15? So again, we have 4 layers. Can the temperature be 15 in the troposphere? Yes, here's 15 right at the ground. Can it ever be 15 in the stratosphere? Nope, the line never gets that warm. How about the mesosphere? Nope. How about the thermosphere? Yes. That's how I would answer these questions. It doesn't kill you to look at all 4 layers before you answer the question. The troposphere. And the thermosphere. Where is the highest concentration of water? Or sorry, no, what is the highest concentration? 40. So the highest concentration, the biggest on the x-axis is 40. And in what layer? So again, they want a layer as the answer here is the highest concentration of water vapor found. Troposphere. So we did those ones together. You have about 8 minutes to get started on your homework, which again, your homework is pages 3 through 4. I think we should probably do a couple of the questions to begin with. These go to yesterday's assignment. Yesterday's that we were looking at on the front page. So blank is the most abundant element in the hydrosphere. What does the word abundant mean? Abundant means most. So we want in the hydrosphere. So we're looking in the hydrosphere column. Which element is the most in the hydrosphere? Hydrogen. Didn't say what compound, which is those of you who said water. It said element. So right off the reference table. So for the first whole page, you're using the front cover. Actually, I lied for the whole thing. We should have done this for homework yesterday. So that should be pretty easy. This part down here on the back of page 4, that's where we're going to start tomorrow. So stop at question 25. This is actually way easier homework than I expected. We should have done this yesterday.